Okay, geometry students, in this video we will be learning 4 ways to show or to prove that lines are parallel. These 4 ways come in the form of, let me fix this real quick, 1 postulate and 3 theorems, okay? So those are going to be the 4 ways that we're going to show or prove that lines are parallel, all right? If you would, please go ahead and write down this heading for today. The heading for today is Proving Lines to be Parallel. Proving lines to be parallel, the lesson number is 3.6, and be sure and include today's date if you would, please, okay? Once again, your heading is Proving Lines to be Parallel, lesson 3.6, and include today's date. All right, let's continue on. Now, in a recent video, we learned 4 principles concerning the properties of angles, transversals, and parallel lines. Remember, in a recent video, we learned 4 principles that dealt with angles, transversals, and parallel lines. In case you don't remember those, here they are. Okay, we said postulate 15, it was the corresponding angles postulate. If 2 parallel lines are cut by a transversal, their corresponding angles are congruent. Now, you don't students, you don't need to write this down. You already have these in your notes. I'm just reviewing to show you that we did look at 4 principles in the past concerning angles, transversals, and parallel lines, okay? Now, Theorem 3.6, if 2 parallel lines are cut by a transversal, alternate interior angles are congruent. If 2 parallel lines are cut by a transversal, the consecutive interior angles are supplementary. And if 2 parallel lines are cut by a transversal, then the alternate exterior angles are congruent. Now, we learned these 4 properties in a past video, okay? Now we are going to take the converse of each one, the converse. Now listen to me, students. Remember, a contrapositive is always true. When you're given a statement and you find the contrapositive of it, that contrapositive will always be true. However, a converse is sometimes true. So when you have a statement and you take that statement and you find the converse of it, a converse is not necessarily true. Sometimes it is and sometimes it's not. However, in these 4 cases, all 4 converses will be true. Got it? Okay, now here we go. These 4 converses that we're about ready to look at are the 4 ways that we are going to learn today that prove that lines are parallel. So we're going to take these 4 principles that we learned in the last video. We're going to write the converse of this one, 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 and that will be the 4 ways that we're going to prove that lines are parallel, okay? All right, here we go. Let's go ahead and get started. Here's your first postulate of the day, and for that matter, your only postulate, postulate 16. It's called the corresponding angles converse, okay? And it reads as follows. If 2 lines are cut by a transversal, if 2 lines are cut by a transversal so that the corresponding angles are congruent, then we know for sure the lines are parallel. Please copy this in your notes. Obviously, you're responsible for this, okay? If 2 lines are cut by a transversal so that corresponding angles are congruent, then the lines are parallel. Now let me give you a little bit of a picture of this, okay? If, it says it doesn't, sorry about that. That should be an F right there. Yeah, I'm on a roll here of mistakes. Hold on a second here. And let's see if I can just mess this up real good. This should be if, sorry about that. Okay, so if 2 lines are cut by a transversal, so here's my 2 lines cut by a transversal, okay, so that corresponding angles are congruent. So here's what I have. I have if I have lines L and M, I would write this down if I were you, and transversal A. So here's L, here's M, and A. So if I have lines L and M and transversal A, and look, corresponding angles are congruent. So corresponding angles would be many things. We'll say this angle here and this angle here. Those are corresponding angles. And angle 1 is congruent to angle 2. Then I know that L is parallel to M. Do you understand that, students? So if two lines are cut by a transversal and any of the corresponding angles are congruent, then the lines are parallel. That's it. Notice it doesn't say that all the corresponding angles have to be congruent. If just one pair of corresponding angles are congruent, then the lines are parallel. And that's what postulate 16 is teaching, okay? All right, let's continue on to the next principle, which is a theorem. I'll just wait 1 second while you guys quickly copy this down. Please take really good notes on this and please understand this math, okay? Next theorem. Theorem 310 is called the alternate interior angles converse, okay? The alternate interior angles converse, and it reads as follows. If two lines are cut by a transversal so that alternate interior angles are congruent, then the lines are parallel. Okay, well here we go, students. If two lines are cut by a transversal, so here's my two lines. Please copy this down, cut by a transversal. All right, we're going to call this once again L and M. We're going to call this A. Please copy this in your notes, students, if you would. If we have lines L and M and transversal A, and then we're dealing with alternate interior angles. Well, alternate interior would be an angle here and an angle here. Or you could put a number here if you wanted to and a number here. Those would also be alternate interior angles, okay? I'm just going to put mine here and here, no certain reason. So if I have lines L and M and a transversal A and angle 1 is congruent to angle 2, then I can say L is parallel to M, okay? Now please understand that this is the second way that we can prove that lines are parallel. The first way that we can prove that lines are parallel are when corresponding angles are congruent. The second way is when alternate interior angles are congruent. Okay, students? Very important that you understand this, okay? Give you a couple more seconds to copy this down. We're going to move on. Please understand this, okay? All right, now, contain your excitement. We're going to prove Theorem 310. You're responsible for this proof on tests or quizzes. Now, if you're a student who likes to work ahead and try things on your own, please feel free to do that. Just keep an eye up here and check your work as you go and make sure you're getting all the steps in, okay? All right, here we go. Let's prove Theorem 310. Remember, your if is your given and your then is what you're proving. So if two lines are cut by a transversal, so the first thing you do is you draw a picture. To be consistent with what we've done so far, I'm going to call these lines L, M, and A. All right, and then we need a set of alternate interior angles. So I'm just going to call this 1. I'm going to call this 2. Now we are students, just so you know, we are going to need to put an angle right here too. So we're going to put this here as angle 3, and you'll see why during the proof. Okay, students, the first thing you do is you draw your picture, and we've done that. The next thing you do is you write down your given, okay? So go ahead and write down your given. And your given is lines L and M, and we have a transversal A, and you're also given that the alternate interior angles are congruent. So angle 1 is congruent to angle 2. Now, the proof part is your then part, then the lines are parallel. So we're going to prove that L is parallel to M. Now, step 1, you draw the diagram. We did that. Step 2, you write your given and your proof. We've done that. Next, you brainstorm. But students, before we brainstorm, I want to show you something. Let's go back here to a page in the past, right here. Remember what I've taught you guys. Whenever you're proving a theorem, you can use anything you've learned in the past, just nothing in the future. So even though we haven't learned Theorem 311 yet, we will learn that today. But you could not use Theorem 311 to prove Theorem 310. However, you can use postulate 16 to help you prove Theorem 310. That's what we're going to do. We're going to use postulate 16, okay? If somehow I can show that corresponding angles are congruent, then I can definitely state that the lines are parallel. So let's go ahead and brainstorm. Here we go. Watch carefully. Okay, I'm given that 1's congruent to 2. Got it? I'm given that. Well, hold it. If somehow I can prove that 3's congruent to 2, they're called what angles? Corresponding angles. And as soon as I prove that 2 and 3 are congruent, I could then use my postulate 16 theorem to state that the lines are parallel. So how in the world can I prove that 2 and 3 are congruent? Well, hold it. I'm given 1 and 2 are congruent, right? Sure. And I know that 1 and 3 are congruent, right? They're called vertical angles, and we've learned that all vertical angles are congruent. And look, if I have 2 congruent to 1 and 1 congruent to 3, then I can state 2 is congruent to 3 by the transitive property. And there we go. As soon as I state that 2 and 3 are congruent, then I can state the lines are parallel. So that's a pretty good system, or a pretty good idea, okay? So let's see how it goes. Here we go. Let's go ahead and put statements here, and let's put our reasons here. And here we go. You do not have to write all you're given if you don't want to, so I'm just going to write angle 1 is congruent to angle 2, and that's your given. Now our goal at the end is to end up with what? L is parallel to M. Let's think this through. Okay, 1's congruent to 2, correct? Now let's see here. 1's congruent to 2. I can state that angles 1 and 3 are what type of angles? First of all, state their vertical angles. You need to state that, and the reason would be definition of vertical angles. So the first thing you do is you state that 1 and 3 are vertical. Then once you state they're vertical, you can state that angle 1 is congruent to angle 3. Okay, I can state that. So the reason would be vertical angles are congruent. I'll pause a second, let you guys get caught up here. We start off with our given, and then we state that angles 1 and 3 are vertical angles. And the reason I stated that is that I want to state that they're congruent, and they're congruent because they're vertical angles. So I first have to state somewhere that they're vertical angles, okay? Now, next, if 2's congruent to 1 and 1's congruent to 3, then I can definitely state that angle 2 is congruent to angle 3, and that would be the transitive property. Okay? The transitive property. Now, here's where, I mean, if you skipped this next step right here on a quiz or a test, I wouldn't be that upset. I wouldn't take any points off, but really, we have yet to state that 2 and 3 are corresponding angles. So I would throw in my proof real quick that angles 2 and 3 are corresponding angles. And of course, the reason would be definition of corresponding angles. And now you are so done. You stated that 2 and 3 are congruent. You stated their corresponding angles. So you can state that L is parallel to M. And your reason, you can either put postulate 16, or you can just simply put corresponding angles congruent, and that's good enough. Because postulate 16 says if your corresponding angles are congruent, then the two lines are parallel. So students, there we go. That's a really solid proof of Theorem 310, okay? All right, if the video needs to be paused, that's fine. Go ahead and do that. I'm going to go ahead and move on, though. So, okay, next we're going to look at Theorem 311, Theorem 3.11, and it reads as follows. Consecutive interior angles converse. If two lines are cut by a transversal so that the consecutive interior angles are supplementary, then the lines are parallel. If two lines are cut by a transversal so that consecutive interior angles are not congruent but supplementary, then the lines are parallel. Please copy this in your notes. Now, while you're copying it in your notes, we are going to draw a picture of this like we usually do. Okay, and I would encourage you to put this in your notes. if we have lines L and M, and if we have transversal A, which we do. And now notice, students, we're doing consecutive interior angles, so we're going to call this 1 and this 2. And angles 1 and 2 are what? Supplementary. So if we have two lines, L and M, and if we have a transversal A, which we do, and angles 1 and 2 are supplementary, then you can state that L is parallel to M. So now we've learned three ways to prove that lines are parallel. If corresponding angles are congruent, if alternate interior angles are congruent, and if consecutive interior angles are supplementary. So three ways that we've learned now to prove that lines are parallel, okay? We're going to look at one more way in just a second, and then we're going to list out those four ways real quick so you can see those, all right? So this is Theorem 311. Quickly copy this down, then we're going to move on. Okay, Theorem 312, the alternate exterior angles converse, all right? Alternate exterior angles converse. If two lines are cut by a transversal so that the alternate exterior angles are congruent, then the lines are parallel, okay? If two lines are cut by a transversal so that the, now look what we're dealing with the alternate exterior angles. If they're congruent, then the lines are parallel, okay? So here we go. I'm going to wait another second while you copy this down, and then we're going to go ahead and get a picture of this, okay? If two lines are cut by a transversal so that the alternate exterior angles are congruent, then the lines are parallel. And here we go. And I know this is pretty boring to use the same picture over and over, but also understand, students, that it gives a little bit of security too. We're doing it the exact same way over and over, so it's easier to remember and easier hopefully to understand, okay? So if lines L and M, if you have lines L and M and transversal A, then sorry, that's incorrect, I apologize. Transversal A and alternate exterior angles, so we'll put a 1 here and a 2 here. Angle 1 is congruent to angle 2. Then we can state that L is parallel to M. Okay, students, so please understand this. This is the fourth and final way that we're going to learn today to prove that lines are parallel. Now in the end, students, I will list out those four ways to show that lines are parallel. But anyways, here we go. If alternate exterior angles are congruent, then the two lines are parallel. Okay, so very quickly here, let me list out the four ways that we've learned today to prove that lines are parallel. You might want to write this down. It's up to you. It kind of condenses everything down that we've learned today so far. So here we go. If corresponding angles are congruent, if alternate interior angles are congruent, if consecutive interior angles are not congruent but supplementary, and if alternate exterior angles are congruent. If any of those scenarios are true, then you have parallel lines, okay? I'm going to pause a second and let you finish copying this in your notes if you want to, okay? And what I've done here is I've basically taken the four principles that we've learned, the one postulate and the three theorems here, and I've just listed them out so you can see these are the four ways that we've learned today to prove that lines are parallel, okay? Corresponding angles congruent, alternate interior angles congruent, consecutive interior angles supplementary, and alternate exterior angles congruent, okay? All right, and let's continue on. Now, I would like you to turn your books to page 144. We are going to look at numbers 1 through 8. You may work ahead. I have no problem with that at all, but please, students, if you work ahead, keep one eye up here on the screen and check your work to make sure that you are doing these problems correctly. Okay, it's very important that you do that. All right, let's go ahead and get started. I'll pause a minute while you get your books out and turn to page 144, and please take some really good notes on this video. Okay, page 144. All right, here we go. Numbers 1 through 4 of the directions state to match the figure with the postulate or theorem that guarantees that the lines L and M are parallel. Now, students, they've given you some multiple choice that you can choose from, so it should be a little easier than usual. Okay, let's start with letter A here. Notice that 1 and 2 are corresponding angles. So, if corresponding angles are congruent, then the lines are parallel. So let's look at our theorems here. Here it is, number 4. Corresponding angles converse. When corresponding angles are congruent, then the lines are parallel. So number 4 would be letter A. All right, let's take a look at letter B here. Letter B. Now, we have angles 1 and 2. Now, sometimes it helps to turn the figure a little bit, and sometimes it doesn't. It's really up to student. Everyone's a little different. For me, I like my parallel lines to run this way, but that's up to every student's different. But here's your parallel lines. Angle here and an angle here. Those angle here and an angle here. That's alternate interior angles. So if you have alternate interior angles that are congruent, then we know the lines are parallel. So let's see, what theorem would that be? Here it is right here. Number 1. Alternate interior angles converse. So that's going to be letter B. All right. There we go. Okay. Let's move on now to the next couple ones here. Give me just a second here. There we go. And let's grab C and D and pull them up here real quick. All right, now here we go. Now, again, for me, students, I really like to have the parallel lines running horizontal. That's just me. So I'm going to quickly grab letter C, and I'm going to run it this way. That's just me, okay? So here's my parallel lines cut by a transversal. Angle 1 and angle 2, they're alternate exterior angles. Alternate exterior angles. So the answer would have to be number 2. Alternate exterior angles are congruent, okay? And then notice right here on letter D, I'm not going to turn this one, but notice we have parallel lines here, and then an angle here and an angle here. Those are called consecutive interior angles. And students, listen, if consecutive interior angles are congruent, then the two lines are not parallel, okay? Unless they're 90 and 90. That would be the only exception, okay? Consecutive interior angles have to be supplementary. And look what it says right here. Angle 1 plus angle 3 is 180 degrees. So we know our two consecutive interior angles are supplementary. Thus, we know for sure that these two lines are parallel, and we call that the consecutive interior angles converse, okay? All right, I hope this is making sense, students. Please pay attention, and if you need the video to be paused, let the supervising teacher know, okay? All right, let's continue on to number 5. Okay, students, please pay really close attention. Let's take a look at number 5, okay? Angles 1 and 2. 1 and 2. Well, here's 1, and here's 2 over here, okay? 1 and 2. Now listen, students, if we're going to use these 4 methods that we learned today to prove that lines are parallel, understand this line here. Now please watch this. This line here that angles 1 and 2 lie on has to be your transversal. Whatever line the two angles lie on has to be your transversal. So if this is your transversal right here, then here's what we have. We have, hold on one second. Wow, here we go. We have these two lines right here being cut by this transversal right here, okay? And look what we have. We have alternate exterior angles congruent. So line 2 and line 1 would be your parallel lines. So line 1 and line 2, okay? And I know the answers are up here in front of you. I know that, but that's not a big deal the main thing is do you understand how to do this? Okay, now look at number 6. We're dealing with angles 1 and 3. So here's angle 1, here's angle 3. These two angles fall on this line, correct? So that line there, the black line that I just drew, has to be your transversal. That line there has to be your transversal. So I'm going to turn this around so that that transversal is going up and down. Okay, there we go. Okay, so we're dealing with angle 1 and angle 3. Here's your transversal. Okay, now look, angles 1 and 3 are corresponding angles, and they're telling us 1's congruent to 3. So if 1 is congruent to 3, then corresponding angles are congruent. Then this line here and this line here have to be your parallel lines. So line M1 is parallel to line M2. That would be your answer, okay? All right, let's continue on. Okay, students, number 7, we're going to write the converse of theorem 310, and then we're going to decide, is the converse true? So here we go. I've got the theorem right here for you. Let's go ahead and pull this up, if at all possible. Hopefully that'll be possible to do. Hold on one second, please. There we go. Okay, so here's theorem 310. Now we're told to write the converse of that. Okay, if we can do that, that means we're going to take our if part and our then part, and we're going to switch them around. So let's see if we can do that. Here we go. Okay, if let's see, two lines are cut by a transversal, lines are parallel. So if two lines are parallel, then the alternate angles formed by a transversal are congruent. Now, that's not perfect. That's not perfect, but that's pretty good. I mean, look, the then part is the lines are parallel, and I know I'm talking about two lines because it says up here if two lines are cut by a transversal. So if part, the then part is the lines are parallel. So the if part would be if two lines are parallel. The then part would then be, you would take your if part up here and you would write that, then the alternate interior, sorry about that, the alternate interior angles formed by a transversal are congruent. Okay, students, I'm back. Sorry about that. My voice is really bad. So anyways, all that I've done here is I've taken the if part and the then part and I have swapped them. Okay, so that's the converse. All right, let's move on to number 8 here. Now this is interesting here. In number 8, it says to name 6 ways to prove that lines are parallel, and we've only learned 4, or so you've thought. And actually in the past we learned 2 other ways to prove that lines are parallel. So I'm going to type those for you since my voice is doing so bad here. So here we go. Name 6 ways to prove that 2 lines are parallel. All right, well, here we go. Take some really good notes. Corresponding angles congruent. That's easy. Okay, that's one way. Another way we learned is alternate interior angles congruent. Another way is let's see, consecutive angles are supplementary. And another way that we learned is alternate exterior angles are congruent. Now, we did learn 2 other ways in the past you might not be familiar with. And here they are. we learned this. We learned that if two lines, write this down please, if two lines are parallel to the same line, then those two lines are parallel. We learned that. I think that was called the parallel transitive theorem. Parallel lines the transivity of parallel lines. If two lines are parallel to the same line, then those two lines are parallel. We learned that back about a week or two ago, okay? And there's another one we learned in the past. It was called, I'm trying to think of it. Oh, if two lines are perpendicular to the same line, then those two lines are parallel. Okay, so let me get my pen out here. If two lines are parallel to the same line, then those two lines are parallel. And if two lines are perpendicular to the same line, then those two lines are parallel. Okay, so overall, we have learned 6 different ways to prove that lines are parallel. Okay, 6 different ways. Today, we just learned 4 of those 6. Okay, so students, I hope this has been a help to you. Please contact me if you have any questions, and work hard on your homework and do a good job. Okay.